Well, good morning, everybody. Sorry for the short delay there. Not too bad. This is amazing. I can't believe we have this many people survive last night. Okay. So I'm Beau Sanders, and this is getting started with Bash shell scripting. I think a little bit about expectations should be said. This is an intro or newbie discussion. I'm going to assume pretty much that nobody in here has ever done a shell script, or maybe haven't done one in a long time. And you want to learn some basic tools that you can use in shell scripting. We teach a course, have taught a course over the years. It's about 45 hours long on shell scripting. And so today you got about 55 minutes of me and Caleb Cooper. Is he here? Caleb, there he is. I've been looking for you. Caleb's going to do the advanced part. He's going to do the fun stuff in the next session. So I'll try to get us started. I am the academic program coordinator for computer technology at Greenville Technical College, about 2 hours south of here on I-85. And I've been there about 13 years. I'm a certified Red Hat instructor, been teaching in the Red Hat Academy there since 2006. We have taught about 4 different courses. Primarily, we teach Linux Essentials and Linux Administration. We've done some security, NetApps, and scripting as well. So like I said, we're going to assume a few things here because I don't know you guys, you don't know me. I'm trying to figure out where we're going to start here. So I'm going to assume that everybody in here knows how to handle the Linux command prompt. That's what my students call it, command prompt. You probably are or have done some system administration, so you want to make your life easier, make things more manageable. You know a little programming, possibly. It's not really required, but you got to kind of understand some of the programming logic. And you know some commands, and you understand the command structure in Linux. So I'm going to assume that everybody in the room is comfortable with these commands. We're going to jump right over this. We're going to jump over a lot of stuff in this presentation because I probably have more slides than any speaker here. Does this make any sense to anybody in the room? I paid an artist to do, no, I actually did this myself, to try to explain what the command structure is. So we understand the command, we understand where the switches or options go, and we know what arguments are. So just by way of background, Bash is the born-again shell. It is probably the most commonly used program in Linux. You don't count the kernel. And this is what you see when you log in to a remote terminal. It's what you see if you open a sudo terminal. It is the command prompt. That makes it an interactive shell. What a lot of people don't realize, especially newbies to Linux, it is a powerful programming language, a scripting language. It allows you to do automated tasks. Basically, anything that you can do in Linux, you can automate with a Bash shell. You just have to understand how to put it all together so that you can get the job done that you want. The Bash shell is an interpreter. I think that's important to understand because in programming, most interpreted languages are fairly high-level languages. They're fast to develop. There's a lot of built-in things that makes life easy, as compared to lower-level languages where you have to code everything. So this is an interpreted language, a lot like Perl or Python, PHP, Ruby. Those guys are all interpreted languages. One of the things that we have to do in Bash shell is identify the interpreter that we're going to use in the first line of a script. Now, this is not required. You could leave this out, and the operating system will just assume you're going to use the shell that you're logged into, which does work. But if you want to use your script or send your script to somebody else, you need to identify the interpreter. So we have this thing called the shebang. The shebang is a pound sign and a bang, an exclamation point is a bang. And that followed by the absolute path to your interpreter gets you started on your shell script. Another thing that you have to do to make a shell script work, you have to set the execute permissions on for the class of user that you want to use the script. And when I teach this at school, a lot of students forget to do this in the early days, and they wonder why their script does not run. But you need to chmod your script. A typical octal notation might be chmod 775 in your script name to get that permission set. You also have to have access to your script through the path. A path is a set of directories that your operating system looks through to find commands. Every operating system that I know of has one. So you could put your script in a bin directory, an SBin directory, or you can use some of the syntax here. Most of the time people use / in front of their script name, which appends the current working directory to the default path, and your script will run. That is also something that new users tend to struggle with until they get used to it. Now, I find it interesting in Red Hat Linux that all users have a bin directory in their default path, but the directory does not exist. If you're going to use that directory, you have to create it one time as a non-root user. And so mkdir /bin should do it. All right, so that's a real quick kind of ramp up to what you got to do to start using your scripts. So first off, we have to be able to include variable values in our scripts. There are basically two types of variables in Bash shell scripting. Shell variable is the most common. It can be anything really. Very simple to do. Bash lets us do this on the fly. It can be used as long as that shell is open. You close the shell or you unset the variable and it goes away. So like I said, there's two different kinds of variables. An environmental variable is a variable that can be used in more than one shell. So most of us use local variables. We write scripts unless we are going to export the variable so that we can use it outside the shell. So to create a variable and give it a value, A equals apple, pretty simple strategy. Now to dereference that variable, you have to precede the variable with a $sign. So if you want to use the value that's in that variable, whenever you dereference it or have it in your script, you have to precede the variable name with a $sign. Now that variable will be in memory as long as that shell's running. Sometimes you may want to release the variable. The command to do that is unset in the variable name. Now I mentioned environmental variables. Environmental variables are stored in the kernel. There are things like process IDs, user IDs. All of the context of processes are environmental variables, and this is what we're typically used to, but we can do the same thing with shell variables simply by exporting them. And the general best practices on exported variables is to name them in all caps so you remember that they are exported. But so all you have to do is promote a shell variable with the export command followed by the name of the variable you want to export. and then you can use it outside the current shell. Now, changing gears a little bit, we need to understand standard in and standard out if we're going to do anything creative with scripts. So all operating systems have a concept of standard in, standard out, and standard error. But we're not going to worry about standard error today, but standard in typically is the keyboard, but it can be something else. Standard out is typically the monitor, but that can be something else. So that creates something called redirection, and we use the greater than or less than symbol to redirect the output of a command, and that provides a lot of opportunities for us. So for example, here we're just redirecting the output of the PS command into a file named sluggish.txt. Notice there's no return to the current standard out because we have redirected the output of the PS command. So we want to see that. We've got to open up sluggish.txt to see that output. So that's just redirecting output. Another neat thing you can do with redirecting output is append an existing file. Now this will actually create a new file or append to an existing file. It's great to use two greater than symbols when you want to do things like create a log of activity in your script. Use this quite a bit. Redirect input, you can use a file as input into a command. One of the best examples of that is the mail command. If you want to send some type of file as to a mail client rather than write it, you can just redirect it as we see on the bottom here. So very quickly, kind of a refresher there on redirecting output and redirecting input. So I got to go fast because I got a lot in my 55 minutes here, I think. So some commands that I think that you're going to have to understand and to really get a good benefit out of your script, to be able to do some nice things with scripts. The easiest of these is echo. It just echoes whatever you want, whatever you feed to echo, and you can redirect it to a file or to another command or something like that. So echo doesn't really have too many options. Then some string, typically redirect that to a file. That's one of the first commands most people learn. Now we're going to jump way over a bunch of things and get to a command that people don't learn too early in our classes. Grep, the general regular expression parser. Grep is huge. We use grep all the time in Linux. Grep is so huge, there's actually 3 different kinds of grep. I tell our students to use egrep because it kind of has all the bells and whistles of all the other greps. But grep is a way to, is used to match a pattern, sometimes called a template, a series of characters in a file, pull out the lines that match whatever that pattern is. And a lot of options on grep. We don't have time to go over too many of these, but grep is pretty powerful. The pattern you can be very creative with the pattern. It can be as simple as just a string. It can be a regular expression. It can be lots of things. Another neat deal with grep is you can invert it, and that's very helpful. We do a lot of exercises in class with vowels and consonants, and drive the students crazy about that. But basically all you do is invert the string. If your string is A-E-I-O-U, invert it and you get all the consonants. So it's an interesting tool to be able to use. Now pipes, I was talking to a guy outside about pipes. Pipes are always very important in scripts. It's a little bit different than redirection because you're basically joining commands together into something called a process group when you use pipes. So typically the output, what you're doing is you're piping the output of the command on the left of the pipe to the command on the, will be the input to the command on the right of the pipe. The pipe is a vertical bar or vertical line, and it's one of the best named characters on the keyboard because it looks like a pipe. Now, the reason this is important is we can combine grep with other tools through a pipe and create a filter. And that's how we filter huge amounts of data into something that we can use. So for example, here we're not using a pipe. We are grepping for a string ROOT in the Etsy password file. And we got a couple of lines of that file that contain root. Now in a pipe, to create a filter, first the typical way to do it, there's always more than one way, but the typical way is to grep a file and then feed it into the pipe and either, process that data, process whatever you're filtering. Word about cut and paste, because cut and paste is real important in scripting. We don't have a clipboard in the command prompt. Cut and paste is completely different at the command prompt. And cut has a lot of options, paste, not too many options. So in cut, you basically can cut a file based on bytes, characters. You can cut based on a delimiter, but it is a way to extract data from in a file. If you've worked with flat database files, just regular text files that are used as databases like Etsy PassWD, this is a very good way to cut and paste. We'll show you how to do that with the cut command. Cutting based on characters, the simple way is just cut based on a character position in a line. You can cut from the character to the end of the line or from the beginning of the line to a certain character, or you can cut from one character to another character. So there's lots of ways to do it. Here's a pretty simple example. Once again, we are grepping. And Caleb's going to tell you about regular expression in the second session. That's an extended regular expression for the argument, or for the option there on grep. But it's basically looking for numbers, for digits in the pros interrupts file, and we're piping that into the cut command and cutting the first 15 characters. Now, there's actually a couple of ways we could do that cut. This is a simple way, cutting character 1 through character 15 to get the useful data out of that output that we filtered. To use cut to delimit, once again going back to a flat file database like the Etsy PassWD file, you have to define the delimiter, whatever the delimiter is. Could be a colon, semicolon, comma, whatever. And then you cut by field based on how many times you go across the line based on the delimiter. Now, pasting is really basic. Pasting is when you combine two or more files together to create some useful output. And pasting starts on the top line of each file and basically combines the two files together. Imagine having one file that has maybe a list of names and another file that has a list of phone numbers, and you want to match those up into an output file. You could paste the two files together, redirect the output, and you would have a useful file. Now, another big jump. These are tools that we need to kind of have our head around to be able to create an administrative script, and that's pretty much what we teach. Return values, sometimes called exit status, depending on which book you're reading. All commands in Linux, when they are executed, leave a return value, 0 through 255. Typically, the return value is going to be 0 or 1. Depends on how the command is written what the return value might be on a failure, but success is always a 0. If it is a non-zero number, something went wrong with the command. This seems like a minor thing, but it actually is a big deal because you can use return values in your scripts to figure out if something is working or not, and then correct the problem with additional lines of code in your script. So how do you see the return value? If you want to see it, there's a special variable that contains the return value of the previous command, which is a question mark. So you echo $? And you will either see a 0 or a non-zero number up to 255. Now, Caleb asked me to do conditional statements, so we put that in here. There are a couple of ways we can handle conditional statements which take advantage of the return value we just talked about. It's a way to have two commands work together, and based on the success or failure of the first command, we'll determine whether the second command works. So in this little example, we create a file called numbers.txt, and we want to move that file to a directory if that directory exists. So in the second line of code here, we make a directory, temp boring, and then we move numbers.txt to temp boring. And it will work if temp boring exists. And so certainly it exists because we made it there with the mkdir command, run ls, to see that the file we created in the first line is not in the current working directory anymore. So it moved. That's a pretty simple, the ands are easier for students to understand than the or. The or is exactly the opposite of that. It only, the second command only runs if the first command fails. So in this example, we make the directory temp mostly boring and then move our primes text to it. And why would that make dir fail? No mostly folder, exactly. So if they put a -p on there, it would have worked, but they did not. So the mostly directory does not exist. Therefore, the make dir is going to fail, and the condition is going to fail. So the return value is not going to work. It's going to be higher than 0. All right. Here's another example, and this is a pretty good example of a conditional or, in that it is going to chmod a command, rather chmod a file if the file exists. If it does not exist, it's going to echo an error message. And so this is a good example of how to use an or conditional statement. Now, one of my favorite commands in scripts is the find command. It's a pretty complicated command because it has 3 parts. You don't have to use all 3 parts, but it's a very powerful command, and I read a lot of other people's scripts, and I see it's used a lot by a lot of people. And so the 3 parts to the find command after the command itself is a starting point for the search, some criteria for the search, And the part that makes the find command really exciting is the third part, the action part, where you can perform a command on the results of the search. So you can create really useful scripts using the find command. So in this very simple form, in this case, we're running the find command on the Etsy directory. The find command has what we're calling the non-standard command line switch. Like a lot of commands in Linux, the options depend on the command, and this is a non-standard format because it only has one hyphen in front of it. But so looking at the files in the Etsy directory by name, I want to find all of the files that end in .conf. There are other ways to do that, but that's a way to do it with the find command. What really makes the find command interesting to me is it has access to all of the information in the files inode. So you can use the find command to dig deep into your file system and find commands based on a lot of different possibilities. And now the action part basically just says, okay, now we've found a group of files based on the criteria. What do you want me to do with them? If you don't have an action statement, as we saw earlier, it's just going to list them on to standard out, which is not too exciting, but we can actually execute a command on it. So this syntax is a little bit awkward because you have to have a placeholder for the output of the find command for the list of files that you found, and then you do whatever you're going to do to them. So in this example, we create a directory called tempbig. We look in the Etsy directory, starting in the Etsy directory, for all the files that are over 200K, and then we exec the cp command to copy those, and then we have to have the left and right brace there as the placeholder for that list of files, and then we have a second argument, which is the destination for that copy, /temp/big. Now, there's one other little problem for new guys to scripting. We have to escape a semicolon to terminate that exec, which is the \semicolon you see there. And if you don't want any error message and stuff, you can dump those off to dev null, which we haven't discussed standard error, but that's what the two greater than is there, is sending any error messages off to dev null. So that's just a quick example of the find command. Another problem or thing that we have to consider when we're doing scripts is how do we get variable values into the script? There's basically two ways to do that. We can do it with positional parameters, which is the quick and dirty way, or we can make the script interactive. In my scripts, I'm pretty much doing things the quick and dirty way. And positional parameters, basically, another way of saying that is we use arguments to send values to variables that we have in the script. So we can have, this actually works pretty good up into 9 until you hit more than 9 variables. If you have a lot of variables, it gets much more complicated, but 1 through 9 works pretty well. So $0 in a positional variable is actually the name of the script. 1 through 9 are up to 9 arguments after the name of the script. If you have more than 9, you have to do a Google search on the shift command, which is very clumsy. The other way to feed values into the variables is to make your script interactive, where the user can actually be prompted for values, and then based on their response, the values are passed to variables. And this is very common in programming, and it can be done very easily in script writing. Definitely want a prompt. You don't have to, it's not a default. You want a prompt, you can do creative things like hide the response for password fields. You can time out after so many seconds, that kind of thing. You can also populate arrays with the read command. So another thing that is important, you may want to protect data so that it can't be clobbered. So you can also use read only in addition to read. So in this little example, we are trying to collect the zip code. We use -P to prompt for zip code. And we echo the value of that zip code. In the third line, we make the zip code read only. In the fourth line, just to prove that read only works, we try to change it, and then we echo zip code and or echo zip, and we'll see that it was not changed. I think this is the last of these tools that I think we need to have our head around to script. And you know, all the scripts in the world have to run, and one thing that we like to do is not be around when a lot of this administrative stuff is done. So cron tab's very important, just a scheduled task. And I'm a big user of cron tabs. I show my students some of the servers I administer, and they have hundreds of cron tabs in them, or cron statements in them, and it seems a little bit silly, but you can do so many different things with it. So understand how to enter a cron statement. We could talk probably 30 minutes about cron by itself. It's very flexible, very powerful tool, and there's a number of ways to run cron. It's very mature. It's been in Linux since day one. Here's just a simple cron tab. Could be for root or for any user, and based on the values of the first 5 columns determines when a particular cron statement is going to run. So I bring that up as a tool that you need to get your head around. So with all of that, how do we put it to work? Well, I talked to several people about this presentation that I know some of them are in the room here. You can make create a lot of very useful scripts and never do any branching or looping or anything like that. But this is where you introduce programming logic to what otherwise is just a list of commands. And so this is where we make it really smart. And so there's, I want to go over some syntax here on how to create a branch. Some people call those decision statements, and also some basic loops. So we probably all heard of if then else statements or if then statements. We can do those in Linux without any big problem. The syntax is a little different than other languages. To close an if statement, the last keyword is fee, which is if spelled backwards. All of these statements, you reverse the first keyword to close the statement. So the syntax is fairly straight up. The hardest part about an if then or if then else statement is to remember to put some carriage returns in it to make it work right. So to open a if statement, if a certain condition exists, then do these commands. When that condition doesn't exist anymore, finish. So that's just an if then, and then if then else. If this condition exists, do these statements, but if it does not exist, else do these statements. And that makes it even more powerful. Now, the carriage returns are very important. You have to put a carriage return after the condition, then has to be on a separate line by itself. Now, all that's well and good. The real power in the if statement is on the condition. Other programming languages use comparative syntax, things like that. Bash makes this real easy for us because all we have to do is run a Linux command as the condition. So it can be just about anything for the condition. Any command can be used for a condition. Some books call the condition a list. It depends on what the condition is, I think, whether it's a list or not. And then based on the return value of that condition, it will determine whether the first or second stanza before or after the else actually runs. So that's why the return value is so important to understand. Now, there is an else if clause in Bash shell, which a lot of people like. Basically, that extends the if statement. Personally, I use something different. I use a case statement instead of this, but if you want to basically have an if inside an if, this is one way to do it. So if the list exists, then do the first stanza. Else if, look at the second list and do that stanza. Neither one of those work, then do the else. And so you can see it starts getting more complicated. And certainly you can nest ifs inside ifs for as long as you have patience, I guess, and try to do it that way as well. So a simple if statement using a positional parameter here. We're catting a little bash shell here. You can see that we have the shebang in the first line, identify the interpreter. I didn't say anything about comments. We pound our students on that in school. We want well-commented scripts, which most people don't do that, including myself. But if there's a pound sign in the first character of a line, then that's a comment. So in this little if, then, else statement, if list $1, in other words, we want to list whatever the first argument is in this script. If it succeeds, if the ls command succeeds and we get a 0 on the return value, then chmod that particular file. Else, we say the file $1 does not exist. So that's a real good example of how you can use the else clause. Most people get into that pretty fast and understand it once they play with it a little bit. Now, I do have one other command, which is not really a construct, but the test command is really, really popular. This is a command that you can use for the condition on an if statement, and it does just what the name implies. It tests. And what makes the test command special is it doesn't return anything. There's nothing returned to standard out. All it does is change the return value. So if you want to test to see if a file exists or test to see if a directory exists or whatever, the test command is a quick and dirty way to do that. So in this example, it's basically the same example before. You noticed in the output in the previous run on this script, we had an error message come out of ls, and that looked kind of sloppy. So we used the test command, if test for the existence of $1, just change the condition here. The rest of the script is the same. Then all we see for the return on the else clause is the string, the file foo in this case, does not exist. So it makes it nice and neat. Test has a lot of options, which allows you to do a lot of creative things. Now loops. If you want to scare new students to Linux, start talking about loops. They get real crazy about it. But loops are hugely important in scripting. Basically, it's a way to run a group of statements based on a condition until that condition changes. And so every time you go through those statements, you iterate or go through a loop iteration. Use loops for things like reading files line by line, hugely important in scripting. If we had time, we could go into how to design menu systems with loops, perform a number of tests, count items. There are a lot of things you can do with a loop. Probably the most recognizable loop is a for loop. For a certain set of variables, go from a starting value to an ending value, then perform a list of statements or a list of commands. Be sure and increment or de-increment your iterator in a for loop, and then go through it again. While loop is similar but different. While a particular condition is true, do the loop, and then once that condition is not true, come out of the loop. The until loop is the opposite of the while loop. While the condition is false, do the statements. If the condition becomes true, then break out of the loop. So each time through a loop, through a group of commands, is called an iteration or cycle through that loop. And there's some creative things that you can do with iterators as well. So the syntax for the for statement in Bash shell scripting, start the loop with a for statement, define your iterator, the keyword in has to be there, and then a list. Then do needs to be on a separate line, a list of commands, and then end. So that would be a very basic one. Examples of what the iterator could be, for example, the iterator could be a script's arguments. $, asterisk would go through all of the arguments in the command line for the script. Another example might be for all the files in the SE directory that end in conf. The bottom one there is really interesting because that's an example of command substitution, which I think Caleb's going to do in the second class today. And so you can use commands as a iterator as well. So I think it's mandatory that you learn how to count when you talk about loops. So here's a little loop that we use in class to count. We're using the test command. And notice we have our shebang up there, define our interpreter. We start the loop, we test for the first argument, see if it's greater than or equal to 10. Then we have a loop that is nested inside the if statement. And notice the syntax changed a little bit here. This is typical of how a for loop's written now. You initialize the iterator, I equals 0, set up how you're going to compare the iterator and then increment the iterator. So you got 3 parts there. That's kind of a shorthand way of setting up the for loop. Then go through the statements, which is just an echo statement. Come out of that when the condition does not exist. And if the argument is not equal to or greater than 10, which is the intent of this loop, then there's an error message. So it works. This is kind of how we teach this stuff in school. We show the script, then we run the script. Notice that the argument for the sample loop script is 20, so we count to 20. Not too sexy, but it does show you how the loop works. Now, this to me is really important because if you're going to be successful with your administrative scripts, you got to be able to read a file into your script, and we do that with a while loop and the read command. So while read some variable name, there's nothing magic about my file. You'll see we didn't use that in the example in a minute, but so while read some variable name, do and echo, basically echo that variable, and then done. It's very simple. And you redirect standard in whatever file that you are trying to read into the end of this loop. That is the most peculiar part of this syntax, is that the redirection's at the bottom. So here is a little example of this. I want to read the etc passwd file into the script. The variable name is input line. Notice that we are trying to, or we will cut the username and cut the home directory out of the etc passwd file. And while we have those values, we're just going to run an echo statement to regurgitate that information to the standard out. So, and an example of several of the things we've run over here very quickly today. So it does work. We run the script. We notice I piped it into more so that I would get a full screen here. Then I cut it out because it was too long to put in the slide. But anyway, it does work. How do you terminate a loop? This is another question that comes up. There's a break command to break out of a loop. If something goes wrong, you want to break out of a loop. You don't want an infinite loop. That's a big problem in programming. So this is just another example. Notice the if-then statement at the bottom, which is a testing for a certain condition to break out of this while loop. All right. Thought this was going to take forever, but I'm flying through it here. Too much coffee this morning. So I thought that, you know, to wrap this thing up, I would just show you some scripts off of some servers that I run, and there's nothing, I mean, these scripts were written for me. So they're really not prepared for public consumption. But just an example of a script, IST 190 is our introductory essentials class in Linux, and on the first day of class, they don't know what they're doing, and I want to give them access to a server where they can tinker around at the command prompt, but I don't want that information to stay on that server, so I want to blow up that account and rebuild it, and that's basically what this little script does. So it's using some of the commands that I mentioned at the beginning. Hadn't even looked at this script since 2014, but you can see I've had it a while. I like to put a history of a script in the file because I forget what I do most of the time. But you can see that we are owning the file. Just let root own the user account for a second. We remove the home directory. We copy a fake skeleton to it, not using the scale, but something else I created for the student to have, and then chown it back to the student, group it for the student. Yes, there's a way to do a chown and a group in one line, but I don't know why I did it this way, but I did. Probably the hardest thing about this script was setting the password from the command prompt. So I echo the password through a pipe into the passwd command. And the interesting thing here is there is a switch on passwd to accept from standard in. So that was kind of nice. And we haven't mentioned logger. I log everything because I'm paranoid that things don't run. So logger just sends whatever that text string is after logger to the message file, and then we echo at the bottom. Basically, this goes to standard out for the script, which is emailed to the root of this server, which is me. It basically says this script was run. That's a function of the cron tab. The reason I put this little script in here is that I created a website called geekglossary.com a long time ago. Last summer, I rewrote it in PHP, in MySQL as kind of a summer thing. I was teaching a PHP class, and I wanted to back up the data. I got about 24,000 terms in this database. And so I wrote a PHP file to actually create the backup, but I needed a way to run it on the server. So I wrote a bash shell script to run the backup underscore data PHP file. This is only noteworthy because it's a way to do, to run a PHP script or file from bash. I'm a big fan of wget. Zach Underwood in the audience, one of our former students who's done very well. I'm very proud of Zach. He actually showed me wget the first time. It is like a Swiss Army knife. It does all kinds of things. Great command. And I also like to, the third line there, I like to send myself emails. I get about 300 emails a day, and it just sends an email to me that this thing ran, so I don't have to worry about it. Now, let's see. This is the reason I chose this script. This is one of the first scripts I ever wrote, and I use it all the time because I screw up ownerships and permissions on my web server all the time, my main web server. So I wrote a script in 2009, kind of been massaging it ever since then. Notice there's no heavy-duty branching or looping in any of these scripts. It's just a bunch of commands, but I use logger. I use the find command. The find command pulls out all the files and sets the permissions for those. All the directories, sets the permissions for those, changes the user and owner, and does a little bit with it puts some messages in the message file when it starts and when it finishes, so I can kind of see how long it takes, that kind of thing, and works pretty good. So I chunked out a piece of this file because I had some stuff a student wanted me to do for them, and I didn't think it was really helpful. So that's why there's a big gap in there. So I guess we're pretty close to on time. Are there any questions? I know I went through a bunch of stuff fast, but that's 45 hours and 50 minutes. Okay. Well, they should be the same. Yeah.
There's a lot of concern these days in security of programming, and of course that's mostly referring to like C and Python.
Right.
Such. Is there anything that we need to be concerned about in terms of keeping our scripts secure?
I wouldn't recommend showing them to a bunch of people at Linux Fest. That's not real secure. I thought about that after I did all this. I said, oh, it could be a Russian spy in here. But I didn't repeat the lady's question in the back. She was asking about the syntax for more, whether to use a pipe or not use a pipe, and you can go either way with that. And the fellow up front here, did we get him on the podcast or whatever we're doing? The YouTube cast. Okay, so security on shell scripts. Not like the other languages you're talking about. I've not read anything about that. I've not had any issues myself, so I guess I'm not a good person to ask that question. There are a lot of scripts on the internet that people share. I'd be very careful about that. Make sure if you use any of those, you know exactly what they're doing, because they may get you. Anything else? All right, so I want to give you a couple of things here. Most of this material that I very quickly went through came out of some courses from Red Hat Academy. Hopefully they don't mind me sharing a few screenshots. I found a book years ago that I like on shell scripting. It hasn't been updated. It came out a long time ago. A fellow lives in Atlanta, teaches school in a community college like me, so maybe that's why I like it. But it's a very simple book, and we've used that for years. So I suggest those to you. being a first-time speaker itself, I didn't know exactly the protocol for distributing slides. I always make slides available to my students. So if you want these for any reason, you can download them. If you would like a resource list, there's an autoresponder at cell 15 at beausanders.org. It gives you links to this stuff. Plus, there's a list of about 10 textbooks on Bash shell scripting that you might find helpful. So with that, I appreciate your attendance on what's not the sexiest talk we've had here, but it was full of stuff.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.